With its 79 moons, strong winds, enigmatic sounds, whirling patterns, and a brilliant aurora, Jupiter has long been a source of fascination, surprise, and intrigue. Music. This video will examine the amazing 10-year journey that the Juno spacecraft has taken. For decades, there have been numerous attempts to learn more about this giant planet, and NASA's $1.13 billion Juno mission may have been the most successful. As a result, the spacecraft that has learned so much about Jupiter was named after the Roman goddess Juno, Jupiter's wife. We have made multiple attempts to research Jupiter, and you can help us by liking and commenting on the video. You may also subscribe to our channel to receive the most recent information. Jupiter has enchanted humanity. Music. NASA reveals breathtaking new Webb telescope photos of Jupiter. Jupiter is 365 million miles from Earth at its closest points and 600 million miles from Earth at its furthest. Because of its gaseous atmosphere, lack of a solid surface to land on, massive size, strong magnetic field, and lethal radiation, studying Jupiter has not been easy. Despite all odds, NASA launched its ambitious Juno mission on August 5, 2011, with the goal of taking on the gas giant and revealing the genesis and evolution of Jupiter. The James Webb Space Telescope, the most sophisticated telescope ever to fly, is used by the near-infrared camera NIRCam instrument. These new photographs show how well it can capture the invisible infrared light necessary to comprehend Jupiter's atmosphere. The remarkable resolution of these amazing images of Jupiter reveal details never before seen. In general, these new photos offer intriguing insights into the composition of Jupiter's storms and what propels their revolution, and scientists hope that these findings will help them solve long-standing mysteries about the planet's atmosphere. What assignment did Juno have? Although it wasn't simple, Juno accepted the challenge, and following a series of orbital adjustments and maneuvers, the spacecraft was able to reach Jupiter's orbit on July 4, 2016, getting as near as possible. High-tech tools like magnetometers, microwave radiometers, and energetic particle detectors are available on Juno to help with its operations. In order to get the greatest photographs of Jupiter, Juno also has a special visible light camera telescope called JunoCam. This camera has provided us some of the most beautiful images of the planet, revealing many secrets about the giant planet, including the majestic south and north poles of Jupiter. The spacecraft is the first to get a clear and precise look at the planet's poles, allowing scientists to delve deeper into the numerous storms and cyclones at the North Pole. It appeared that the cyclones were more octagonal, while at the south they formed a pentagon. For Juno, they could only speculate what the poles would look like. This is the first time that the spacecraft has captured the extremely rare sight of Jupiter's southern pole, completely overwhelmed by storms and cyclones. It looks like something from a Van Gogh painting. Additionally, Juno is the first spacecraft to approach Jupiter. Jupiter and its satellites family photo is captured by Juno. Jupiter is well known for its several satellites, including the Himalaya, Io Europa, Ganymede, Callisto, and Amalthea. During its 8 flybys, Jupiter's mission focused only on the planet and its extremely frigid moons. Jupiter and its well-known moons were perfectly photographed by the Jupiter camp. Europa and Io. The photo, which showed that Io was closer to Jupiter than Europa, was taken while the spacecraft drifted 27,516 kilometers above the planet's foggy atmosphere. It almost looks like a family photograph all at once. On September 12, 2019, during a near flyby that braved Jupiter's tough atmosphere and approached within 8,450 miles of the planet, another breathtaking image depicts the shadow of Io falling on Jupiter. Jupiter's cyclones. The information gathered also showed that the Earth was continuously churning due to numerous powerful storms and densely populated cyclones. Cyclones are linked to an inward rotating wind system and are mostly linked to rainmaking circumstances. On the other hand, anticyclones do not create any precipitation as you push the air lower into the planet's surface. Scientists, using the data, Gerald Eichstud and Sean Duran produce an image of a large storm known as NNLRS-1. Each storm is reportedly large enough to engulf North America, and this beast of a storm appears to be roaring along one half of the world as multiple smaller cyclones are visible nearby. Another image, obtained in exquisite clarity by the Juno cam, appears to show a group of cyclones twirling about in a captivating dance. The picture was obtained from a height of approximately 18,000 miles or 28,567 kilometers above the cloud cover. The inner clouds of the behemoth storm appear to be moving counterclockwise, while the outer clouds appear to be traveling in the opposite direction. When amateur astronomer Samuel Heinrich Schwab first saw Jupiter's mark in 1831, the behemoth storm enthralled people with its powerful winds. In the southern hemisphere of the planet, Juno flew very close to Jupiter during its 7th flyby to capture the majestic anticyclone. On Earth, a storm would eventually die after hitting land, but on Jupiter, it rages on because there is no solid surface. Scientists say the storm was likely there for years before it was first observed, and no one knows how it gets its distinctive red color, but if you ask the Great Red Spot, the answer might be cannibalism. The winds reach speeds of between 430 and 680 kilometers per hour. The Great Red Spot is an anticyclonic oval that is roughly 20,000 miles long, 10,000 miles wide, and between 8,000 and 10,000 miles deep. The French astronomer Lavier named it upon its discovery because of the storm's red hue when viewed through small telescopes. According to new research, the giant storm occasionally shrinks and grows to maintain itself, but the data gathered from the Juno mission strongly suggests that it is on a shrinking trend. The storm is thought to have existed for at least 350 years, which makes its longevity even more amazing. The south and north equatorial belts, two bands of storms in Jupiter's equatorial zone, are surrounded by numerous impressive structures and vortices. They bake at temperatures above 328 degrees Fahrenheit and spin at about 200 miles per hour opposite each other, giving the upper atmosphere a look similar to a hurricane. The storm casts an enigmatic radiative glow in the atmosphere, but its relationship to Jupiter's formation is still unknown, as is what causes its long-standing longevity. Scientists think that Jupiter's upper atmosphere helps to stabilize the phenomenon by redistributing energy and angular momentum. Additionally, experts have hypothesized that the storm's high wind speeds, which activate latent heat, are the cause of its heat. NASA's satellite displays the incredibly strong auroras of Jupiter. Like the beautiful ones we see on Earth, Jupiter's auroras are the strongest in the solar system. These strong X-ray auroras are usually produced in the planet's poles, and there are a number of theories as to how they are created using measurements from Juno. Scientists hypothesize that extremely strong waves are produced by the planet's magnetic field oscillations. When supercharged particles are carried to the poles by these waves, they collide with one another and enter the magnetic field, creating streams of luminous light that are superimposed on JanoCam photographs, the breathtakingly beautiful lights. On Jupiter's two sides, it is stated that these auroras are so strong that they could momentarily power all of human civilization. Thus, one can only image what a breathtaking sight this may be against the black expanse of space. Jupiter's auroras are fueled by particles from Io interacting with the solar wind, according to Juno's ultraviolet camera. Scientists have been able to detect the distinctive auroral features, such as strong and concentrated auroral bands, thanks to Juno's several orbits around Jupiter, which have given them an unprecedented view into the aurora's three-dimensional structure. Wavy clouds are seen by NASA's Juno spacecraft. Because of the dynamic nature of their atmospheres, clouds on gas giants display a variety of unique patterns and colors. On Jupiter, however, the clouds are primarily made up of compounds that contain ammonia, water, and sulfur. Every 53 days, the Genospace spacecraft circles Jupiter, taking pictures from one side of the gas giant to the other. These pictures allow us to see Jupiter's clouds in detail, highlighting their unique shapes. The winds that propel these cloud formations can reach speeds of up to 270 miles per hour. This strong wind dynamic is thought to be fueled by water vapor and conventional currents. These clouds are in a perpetual state of motion, with the main collective cell rising to an astounding 64,000 feet, 12.6 miles in height. There are numerous cyclones of varying sizes in Jupiter's south equatorial belt, each encircled by striated winds. Some of these cyclones have a diameter of hundreds of miles, and one can extend up to 1,400 miles. Below these cyclones is a region where lightning and tumultuous storms produce radio waves that Juno's onboard radio receiver can pick up. The gorgeously crafted and nearly artistic clouds in Jupiter's atmosphere are depicted in an October 2018 photograph. It's almost like gazing into a real-life painting with surrealistic, the spacecraft's 16th flyby captured the beauty of the cloud band team, swirling and producing the most visually appealing image. Jupiter's North Temperate Belt offers yet another, breathtaking view of the planet's swirling clouds. The landscape is eerily lovely, with a multitude of colors and shades and several white pop-up clouds. At the time of this photo, Juno was roughly 400 miles above the cloud tops at around 40 degrees north. The event is also visible with a blazing white oval-shaped anticyclone. Juno's data provides a solution to previous mysteries. Jupiter is a magnificent planet, and these Juno photos showing the deep heat systems in its atmosphere demonstrated that the strong jet streams on the enormous planet appear to go more deeper and longer than previously thought. The pictures also showed that these vibrant belts and ribbons might extend up to 3,000 kilometers, or 1,800 miles beneath the Earth. Although these strips on the planet appeared mysterious to Galileo when he first saw them more than 400 years ago, gravity. Measurements from the spacecraft have allowed us to study the planet's depth and core. The billowy bands that encircle the planet provide breathtaking views, and it is undeniable that Jupiter is a true work of art. Groundbreaking measurements of the planet's atmosphere and internal magnetic and gravitational fields have been gathered by NASA's Juno mission. Since then, Juno, which is now affiliated with the European Space Agency, has discovered more information on the structure of the big planet than any other mission. As a result of this invaluable wealth of data, NASA has pushed back the end date from July 2021 to September 2025. Juno will join forces with the JUICE of European space agencies. Scientists will gain a deeper understanding of Jupiter's icy moons, which may contain hints about life, by interacting with Europa Clipper. Jupiter Ice Moon Explorer will have the opportunity to go up close with Europa Io and Ganymede. The moons may also harbor liquid water oceans beneath their surfaces. Humanity now has a once-in-a-lifetime chance to discover more about our cosmic neighbors thanks to Juno and Europa Clipper. Because scientists think that the ice-covered moon could be able to support microbial life, Jupiter's icy moon Europa has long been a fascinating target for research. In light of this interest, the Juno mission is scheduled to launch a spacecraft to investigate Jupiter and its moons, including Europa. In the upcoming years, we can anticipate some fascinating discoveries as Juno uses its extremely sensitive instruments to measure the thickness and composition of the ice sheet and search for additional plumes. The mission will concentrate on the moon's atmosphere, magnetosphere, and water plumes that rise beneath the moon's icy surface. These plumes suggest the presence of internal liquid oceans, which could provide a habitable environment for microbial life. Thank you for viewing, and if you liked this video, please hit the like button and subscribe to our channel for more thrilling space videos.